This process computes the first 4 linear moments of the sampled data and generates a graph with a number of different distributions. From the graph, you can find the distribution that best fits your data. We go to Event, Our Moments, and select our data and time range as usual. As for all event processes, we need to define our sample rules. Actually, I just want to take a moment now to talk about this historical floods function. You can use this if you have data on floods that occurred before a recorder was taking regular measurements at a site. Here, you need to enter the date from when you do have regular data recorded, so that's the date the recorder was installed, and I'll head back up to Data Selection and change this one to the start of the historical period. You need to enter a carefully considered threshold flow. So this is a value representing a base level, above which you have data for all the floods that occurred in the historical period. It's important, you're hanging your hat on the fact that you know all the floods above this level. Also, the threshold should have a return period of less than 20 years to ensure a sufficient balance between the floods above and below the threshold. Now, where there is an incomplete record, there are 2 ways to consider the historical data. You can simply analyse the data you have, so if we have 35 years of systematic data and 5 of historical floods, the software will compute 40 years of data. A far more sophisticated method is to complete the sample by synthesizing floods in the historical period and analysing both the measured and synthetic floods. Suffice it to say, this is way better. Just tick the box. Go on, do it. That all said, for this analysis, I actually want to have a look at low flows over a 20-year period. A 7-day moving average is a good interval for low flow analysis. It's important to use a moving average for low flow analysis because when rivers are really low, someone could empty their chili bin in and push the volume up, and we need to get rid of such noise. 3 to 7 days is a good time period. I want Event to read the data across the whole year, so our season starts in January and ends in December. Event will produce up to 1 sample per month, but I want 1 sample per year, so a partition of 12 months here is correct. Okay. And here's our graph with these 5 distributions as lines, plus the Gumbel distribution as a spot here. Here's our data, and it's sitting very close to the generalized logistic curve. Here's the table listing the L moments. L1 is the mean, L2 is like the standard deviation, T3 is a ratio of L3 over L2, and it's a measure of the skew of the distribution. T4 is a ratio of L4 over L2, and it represents kurtosis, which is a measure of how peaked or flat a distribution curve is, and therefore the thickness of the tail. In the next video, I'll take you through the fit distribution process, where you can apply the results of the L moments process to estimate the likelihood of drought conditions and do flood analyses.